Alright, good morning, scholars. Here we are again. Today we're going to be talking about compound inequalities. Go ahead and take a moment to write down your title and objective, and then we'll get started. Alright, so yesterday in our Zoom meeting, and for those of you who were not able to come, just to let you know, we're doing Zoom meetings or lessons every Monday. And so if you're in Miss Bab's class, you'll be doing it with Miss Bab, and if you're in my class, you'll be doing it with me. Those are mandatory. We want to make sure to be able to check in with all of you guys. So we just taught a lesson, a basic lesson on inequalities in yesterday's Zoom session. So feel free to contact me or Miss Bab if you have any questions or concerns about being able to make it next Monday. So yesterday, in that, we talked about inequalities, and we said inequalities were just, in math, it's just two numbers that are not the same. Okay, so that's what we did yesterday. So let's go ahead and start out with a definition of a compound inequality, since that's what we're moving towards today. So go ahead and write this down with me. A compound inequality, well, I'll say compound inequalities, are two inequalities joined together by the word I'm going to put it in a different color, and the word or. Okay, so I'm just going to show you some examples and then we'll talk about what they mean. The first example would be if you see something like this. This right here is a compound inequality. We know this because let's look at the definition. It says we need two inequalities. Well, here's one and here's one. It's joined together by the word, and we need to see either an and or an or in between them. There's an and, okay? So this is a compound inequality. That's example one. Let's look at another example. In this example, again, we have two inequalities joined together by one of our keywords, and or. So that is just another example of a compound inequality. So all that this is going to do is it's going to help us when we're trying to graph something on the number line to figure out what x is. Again, we really don't know what x is. That's why it's a variable, right? We don't know what specific number it is, but we do know two things about it because it's compound, so there's two pieces of information. The first piece of information says that x is larger or greater than or equal to 3. So we know the first piece of information tells us that x is greater than, it's our greater than symbol right there, or equal to, because of our line down here, half of an equal sign, greater than or equal to 3. And we're given a second piece of information about that same x, that same number that we're looking for. It's also less than or equal to 8. Less than or equal to 8. So with those two pieces of information, what I'm going to do when I graph is I'm going to graph the first piece of information and the second piece, and then I'm going to put them together. Okay, we'll come back to this example in a minute. I'm going to say example 1, and I'll just rewrite our compound inequality down here. Okay, I'm going to draw us a number line in black. And when you're doing this in your notes, just make sure you leave enough room above it because we're going to need some space above. Okay, so I'm going to go ahead and fill this in. Now, notice that what I need here is I'm using the numbers 3 and 8. So 3 and 8 do need to appear on my number line. But notice that I can't just stick them anywhere, right? We have to keep things evenly spaced. And if I were to have negatives, they would go this way. So usually it's good practice when you're drawing a number line to draw some positives and some negatives, of course with a 0 in between them, and go ahead and draw lines on either side, which show us that obviously after 8, numbers keep going, right? They keep going, and they keep going in the negative direction over here. That's why we have arrows. Again, this is just our generic number line, which is what we're going to be using today in each problem. So let's look at the first part of our compound inequality. Piece number 1 says x is greater than or equal to 3. So in order to graph this, and usually we graph right on the line, I'm going to do it above. I'll show you why in a minute. We start at x is 3. Now we have to ask ourselves, is it going to be a closed or an open circle? Well, because of this half equal sign down here, it will be a closed circle. Then the only other thing we need to figure out is which way does our arrow go? This is saying that x is greater than 3 because the open part of our symbol is pointing towards the x, which means x is larger than 3. So which way do we go to get numbers that are larger than 3? Well, we go this way, right? Because 4, 5, 6, 7, 8, all of the numbers in this direction are larger than 3. So here is our graph of the first piece of our compound inequality. Now let's look at the second piece, and I'll do that in a different color. X is less than or equal to 8. Well, that's kind of a hard green to see. So we look at 8, we find 8 on our number line. Here it is right here. And we'll go ahead and graph this one above the red one that we just did. So I'm going to make a closed dot because of this half equal sign here. Now this is telling us that x is less than because the closed side of our inequality is pointing to the x. So x has to be less than 8. So which way are the numbers less than 8? That way, to the left. So I'm going to draw that one. Okay? Now we know that x has to be both of these things. So what we do is we say, okay, x has to be both larger than 3, greater than or equal to 3, and I'm going to draw, hopefully you can see this, but it also has to stay, it can't go above 8 because of this part, right? So basically what I do is I just combine my 2 into 1, saying, okay, it can be greater than 3, but it also has to be less than 8. So I just took my points down and connected them. I'll put a pink around this whole thing to show that the pink part of the graph is taking them both together. Okay, so x will be somewhere in between 3 and 8. Anytime you have an and connecting your two inequalities, let's just write ourselves a little note. The and means we'll have something that looks like this, where we have 2 points that are connected. They could be open circles, they could both be closed circles, one could be open, one could be closed, etc. Right? But I just want you to see that it looks like this. And you're going to see the difference when you see an or. So let's look at that for our second example. Well, I can't find my black pen. Just kidding, I found it. Okay. So for example 2, let's look at an or problem. We'll look at this one up here. I'll just rewrite it. X is less than 5 or x is greater than 10. So again, I'll just draw out my number line, leaving plenty of room on top. I need to make sure that my number line includes the numbers 5 and 10. So I'll make the 0 start over here. Again, as I said, it's good practice to always make sure you show you don't always have to show negative numbers, but because we're in the lower, because we're not dealing with numbers like 100 or something. Now, if we were dealing with 100, you would definitely not want to draw this all the way out into the negatives. That would take forever. Okay, let's start with our first one right here. X is less than 5. There's no half equal sign here, so we will have an open circle on the 5. And then it says x has to be less than 5. So where are the numbers that are less than 5? They're all over here on the left side, so we'll go that way. Now what about the second piece here? X is greater than 10. Okay, well, where's 10? Here it is. It's going to be an open circle because there's no half equal sign. Ooh, just drew it in there. Didn't mean to do that. It says x has to be larger than 10. Well, where are the numbers that are larger than 10 going to appear? Right, they're going to be up here. So x larger than 10. So you see here, unlike the and, see how the and, they overlapped, and we just took the overlapping section and brought it down to be our final answer? Well, in this case, we see that they don't overlap, and that doesn't mean that there's no solution. It just means that there's a lot of possibilities for what x could be. So if I put it all together and say that x can be less than 5 or it could be greater than 10, here was what my finished graph will look like. I'll just pull both pieces down. Now hopefully you can see this pink right here. So that just says basically x could be over here, it could be over here, but we know for sure it cannot be in this middle region. And it can't be 5 or 10 either because those dots are not closed. Okay, I'm going to do one more example and then we will be done for the day. Okay. I want you to go, oh, and before we do this, let's look again. Remember how we said up here we'd be looking at kind of the overlap, so our graph would look something like this. Well, with the, let's make a similar note for the or case. With or, it's going to look like your graph going in opposite directions and not crossing. Okay, and again, these could be open or closed circles. All right, final example. Okay, now this one looks a little bit different from these, right? There's no word and there's no or. This is basically, though, if you see something like this, and we've seen a lot of these where the x is in between the -1 and the 7. We've seen things like this before. It was a while ago. But basically what this is just another way of writing the and compound inequality. So this is just another way to write the and. So we'll know if we see something that looks like this, where our inequality symbols are with the less than side pointed this way, right? So we have less than or equal to and less than or equal to. This is going to be an and. The other way you can think of this is saying that x is in between -1 and 7. Okay, let's go ahead and graph this. This one to me is actually the easiest to remember, simply because if you look at this visually, x is in fact, the x is drawn in between the -1 and the 7. And that's exactly what we're going to see too when we graph it. Okay, so let's just do each piece individually, just like we did up here. So the first piece we'll do is this. Now this looks a little bit different, right? Usually the x is on the left-hand side, but that's okay. We can still understand what this is saying. Let's start with the x. X is, now the larger side of the inequality is pointed to the x, so that means x is greater than or equal to -1. So let's go down here to -1. It's going to be a closed circle because of that half equal sign. And this statement tells us that x is greater than or equal to -1. So which way on my number line are the numbers getting larger or greater? This way. So I'll go ahead and draw that out right there. Okay. Let's look at the second piece. Now watch this. You see how each of these pieces has one piece in common, simply the x. So with the second piece, x is, now this time the smaller side is pointed towards the x. So the x must be smaller. X is less than or equal to 7. Again, filled in dot. And which direction are the numbers less than 7? Well, it's just this direction. Okay, remember in this situation, an and, they're going to overlap. So in order to draw the whole thing all together, we simply take the overlapping pieces and draw them together. Basically looking at my two endpoints and taking everything in between. So look, I literally see this is x is in between -1 and 7, and that is exactly what our graph is showing us. X could be anywhere in here in the pink, And this whole area is in between -1 and 7. It can't go outside here or outside here. Okay, so that wraps up today's lesson. Have a great day.